as I put this program together, I look for speakers. And it's tough because, you know, I don't want to have the kind of speakers you see at every other conference. And I go through cycles. I leave this conference and I start working on next year's, and I'm pretty excited, and then I start looking for speakers, and it's hard. And about February last year, I was on my way to Shanghai, and it was like one of those travel days that you really hate. And I climbed into a seat in United and buckled my seatbelt and thought about the many hours I was going to be on the plane. And I don't typically talk to people on planes, right? I typically open up my laptop and start typing away. But I happened to sit by a man by the name of John, who's the CEO of a company called Amyris that I had never heard of before. And John also doesn't talk on planes, right? But we started having a conversation about biomolecular engineering of yeast cells and putting yeast cells to work for localized manufacturing. You know, and when John first started talking about it, I'm like, what? You know, what do you mean by waste? And, you know, of course, my mind's going a million miles an hour. And how do you manage waste streams? And how do you manage the yeast? And what do you make, right? And he talked about, well, we make anything from oil and gas to fragrances to active ingredients. And I'm like, you need to come and speak at my conference. Well, the problem is, the earlier I book a speaker, the higher the probability they can't show. So John couldn't make it, but he sent Howard. And Howard is in charge of supply chain and quality for Amyris. And he's going to talk about how we could put yeast to work and localize small manufacturing and really improve the planet. Let's give the floor to Howard. Howard, welcome to the stage.
Thank you. Okay. And in conclusion, Laura, that was a great introduction. Yeah, I am stepping in for John today, so good after lunch, everybody. You know, I think I know a lot about supply chain, but I have to say, this is a pretty impressive group. And every conversation, every question, you guys have taken me to school. So let me see if I can try to give a little bit back to all of you in this presentation now. So as Laura mentioned, I'm going to talk about the potential for reducing volatility within your supply chain through yeast. What did he say? Yeah, he said yeast. So it's a pretty novel concept. Some of you may have heard some of this already. It might be new to others, and we'll talk about some of those ideas. For that, I'm going to give you a brief overview of Amyris and what we do and how we do it, just because that context is pretty important in talking about the challenges and opportunities within the supply chain, talk about some of the examples of success that we're having, and then wrap it up and take some questions. So, Amyris, what inspires us? Well, it absolutely is an inspiration-driven company. You see excitement at every level of the company, from the scientists to the process development team, engineers, quality and supply chain. Although quality and supply chain that I run, our version of excitement is boring, so boring is exciting. So within that, of course, the scientists have the most interesting job, the most exciting job, and that is to basically bioengineer yeast strains. Those yeast strains are intended to produce the molecule or intermediate to the molecule that you need to eliminate chemicals and ingredients within your supply chain that are causing volatility. Now, it's a very mission-driven company, and in that context, we really do view ourselves as making the planet happy, if you will. And one of the themes I've been really happy to hear a lot discussed with this group so far is the ideas around sustainability. And later when I get a little bit deeper into this presentation, I want to talk about that concept of sustainability and what it might mean for different organizations. Now, how do we reduce volatility within the supply chain of our customers? Well, we bioengineer the yeast and we take it to industrial scale fermentation processes, so they can swap out what they're currently using in terms of chemical ingredients that are potentially causing them volatility in their supply chain. So what's our commitment, our promise? What do we want to deliver to our customers? Well, we want to provide them reliable and stable product. But it's more than just that, because a lot of times when you hear about sustainability, people start to think green also. And so they think, well, what do I have to give up? If you're talking about green, you're talking about sustainable, what am I giving up? Am I giving up performance? Am I giving up cost? Am I giving up market share? What am I having to give up? And what we deliver to our customers in almost every case is not just a more reliable and stable supply chain, but it's superior performance, superior cost. So there's nothing that you have to give up. We're not asking you for trade-offs. We're not wanting to provide or requiring organizations to make those trade-offs. So that's our commitment to organizations, and we've been pretty successful so far in doing this. So even though this might sound like a novel concept to you, bioengineering yeast, industrial scale fermentation, providing that product to replace ingredients and chemicals, we're actually the Intel inside of our space. We've already affected over 470 different brands. So the tires you drove in on, the plane you flew in on, the cosmetics that you used, there's a potential that we are inside a number of the products that you interact on a daily basis. So it is somewhat of a novel concept when people first hear about it, but we actually are the leaders within our market, the leaders within our sector. And so for those of you that are involved in sourcing any chemicals, any ingredients, there's the potential for using a more sustainable process that delivers on reliability, stability, performance, quality, and cost, not asking you to make the trade-offs. So that's a big opportunity for organizations. Now, this is kind of the teaser and the context for what I want to present. I want to take a step back and then take a step forward in terms of both the challenge and the opportunity for supply chain. So, statement of the obvious, right? All of you are well-seasoned, well-experienced. You deal with these things all the time. So volatility is the new normal. Well, it's not the new normal. It's been around for quite some time, so it's not so new, right? But when you are sourcing chemicals and ingredients, what are the types of things that you might run into? Well, if you're sourcing from oil or you're sourcing from plants or animals, you can have regional unrest, you can have natural disasters, you can have floods, you can have droughts, pests, you can have collapsing stocks from which to draw upon, you can have regulations. These are all the things we know. These are the things we plan for. These are the things that we can use stuff like simulations to help us do risk analysis and do better planning, do risk mitigation. So well understood, well addressed by most organizations. But there's another way to deal with this. And one of those ways is what I just mentioned earlier, is where you source the material. Rather than taking it from oil, rather than taking it from plants, rather than taking it from animals, this idea of bioengineered yeast and industrial scale fermentation. So statement of the obvious, the known, the things that we plan for. And then there's those things that are a bit harder to plan for. Those things that are time dependent, right? Perceptions change over time. That's a difficult thing to plan for. Right? One day, we might be removing resources from a region and be considered an economic stimulus. The next day, we might be considered exploitive. Right? So on the harvesting, you can be viewed as imbalance, at other times viewed as excessive. And when you look at traditional ways of sourcing a lot of these things, whether it's catalytic conversion or cracking, heavy metals are involved. One day, looked at in terms of waste and pollution as being in balance again, other days being too much, so new regulations appear. Now, this all speaks to what? And this idea I mentioned earlier that was very encouraging to hear from all of you, which is the idea of sustainability. The question was asked earlier, what is supply chain going to look like in 2030, right? So I don't know exactly what it's going to look like, but do you think your requirements for sustainability are going to be more or less? Certainly more, right? That's not even a question. In fact, I heard some people say, well, what does supply chain look now in 2016 as compared to 2000? I mean, what's really, really changed in 15 years versus what needs to change in another 15 years? And there has been some technology advances, for sure, right? Better talent in a lot of cases, better development, and we saw some of the leading industries speak to those points. But the one thing that we can say is absolutely changed from 2000 today is requirements for sustainability. So that's also going to grow going into the future. So what is sustainability for all of us? Is it a constraint or is it an enabler? Right? If theory of constraints didn't teach us anything, it taught us that it's only a constraint because we haven't turned it into an enabler. So Ralph spoke earlier of how he actually addressed some of this already in terms of turning the constraint into an enabler, right? Pipes are better than trucks. Trains are better than trucks. More cost effective, better quality, less handling, all those factors come into play. So even absent sustainability, you would want to be moving in that direction. And so really the question comes to all of us, what does sustainability mean to supply chain? How do we actually enable sustainability in a way that we help grow market share, that we're ahead of it, we're not managing to it. We're saying, well, okay, when the regulations pass, then I'll spend more money to deal with it. Necessarily trying to get more money out of the customers for it, right? So what does sustainability mean for each of us? And I think it means a very different thing for a lot of organizations. Now, for most of you in here, you seem, not just seem, you are very well advanced in your thoughts, and you are thought leaders in the industry. So I imagine your sustainability programs are very proactive, and you're looking for ways to incorporate that and leverage that and be the enabler for your organization to add the value that you can. But I will tell you, in my previous life, I worked as a consultant. I worked with over 30 or 40 different organizations and supply chains. They would also talk about programs like supplier partnering, right? We all have supplier partnering programs. We all have sustainability programs. But the spectrum of what that means across different organizations can be quite dramatic. In leading organizations, supplier partnering really means strategic innovation, right? In other organizations, admittedly, when we talked with them, supplier partnering meant we get together once a quarter with our suppliers and beat them to death till they give us another penny per unit reduction, right? So you have that full spectrum. So what is sustainability? And can maybe some of the ideas that I'm introducing to you spark some ideas around how you can incorporate these into a sustainability program and really enable the value within the organization. And it may not be exactly ours, but it could even be things like this. So the converse of the challenge is the opportunity. Substitute out high volatility sources that are found in nature. So where you find things that have low bioavailability, right? By definition, low bioavailability means you're going to run into volatility within your supply chain. When you look at traditional sources, they may have unacceptable levels of waste and pollution, and even if not today, might be tomorrow. So what are we planning for? In a number of other cases, when you look at sources for high-value chemicals and high-value ingredients, the way in which they're produced is so sensitive themselves. It's the whole chaos theory butterfly effect. Butterfly flaps its wings somewhere over the North Pole. What it's doing there, I have no idea, and our supply chain goes down for 30 days. Right? So how do we deal with those types of things? Well, I've already hinted at the answer, well, maybe more than hinted. Substitute with what, eliminate how, replace with what, and that is with synthetic biology to bioengineer the yeast strains and do industrial scale fermentation. Now, the pictures are interesting, but just to give a little bit more context and understanding, I have a short video that I'll personally narrate for you so you can get a little bit better idea of how we actually do the bioengineering and how we do the industrial scale fermentation. Okay, so our corporate facility is located just outside of San Francisco on the East Bay side, right across the Oakland Bay Bridge. We're called Amyris. This is our R&D facility. This is where we do our bioengineering of the yeast strains. It's a world-leading technology platform. We can develop and screen strains on a level that isn't seen anywhere else. In fact, I think we are the world leaders in living organisms within our banks. It's something on the order maybe of 40 or 50,000. That's how much we can create, and that's how much we can screen. So the concept is pretty simple. We basically look at what you need to replace. We bioengineer a yeast strain that will produce the molecule or intermediate to the molecule to actually substitute out that ingredient or chemical. And we go through a lot of screening until we find exactly the one we need, which is right there. Then we take that particular one and we look at multiple variations of it and we start the scale-up process. And what's interesting in the scale-up process, when we do the optimization, it isn't just for yield and productivity and cost. It's also performance and quality too. I mentioned earlier, and I will continue to say, we do not want you to have to sacrifice one for the other. So we'll take it through half-liter, 2-liter, 300-liter scale, and then to our 200,000-liter scale fermentation process. This is in Sao Paulo, Brazil. Couple hours outside of Sao Paulo, total field of dreams moment, right? You're driving along for 2 hours outside of Sao Paulo, you see nothing but sugarcane fields. So instead of a baseball stadium and a cornfield, there's this metal sculpture in the middle of this sugarcane field that you have no idea what it's doing there. You see it, you see white stuff coming off of it, you think, wow, it's smoke, it's pollution, it's foul smelling. You get up on it and you realize, well, that's not smoke, that's steam. You get a little closer to it and you wonder, why are all these bees buzzing around here? And it's really because of the sweetness of the sugar, and you smell the fragrances. Sometimes, during certain times of years, you got to watch out for the beetles too. They fly around, they're like miniature tanks. When they hit you, you feel it. But it's really this wonderful blend of man and nature. We do industrial scale fermentation, we do centrifugation, we do distillation, and we produce incredible product for our customers. So it's not this concept idea like, well, where are you guys at? How much do you do? We do hundreds of metric tons, thousands of metric tons, tens of thousands of metric tons. We have a pretty significant scale on how we do that. So, 3 important takeaways from this. One is we have world-leading R&D to develop the types of yeast strains to swap out those things that are causing you volatility within your supply chain in San Francisco. We have industrial scale fermentation within Sao Paulo, Brazil. The third and most important idea is go back and talk to your organization and tell them you need to personally assess us in San Francisco and Brazil. They're not such bad places to go to. So there's one of my gifts back to you for everything you've taught me today. Now, at what scale can we do this? Well, I already mentioned the volume we can push through. We also can change over the plants, run multiple molecules, and we deliver to our customers. So think about this. How fast can we do this? How fast can we turn this around? Because maybe I've teased you just enough. Maybe there's some interest or some ideas about this or with others. I mean, it's all about the happy planet, whether it is with us or with others. And you say, well, that's an interesting idea, Howard. Maybe we put you in our 3 to 5 year roadmap and start the discussion. You become part of our sustainability evaluation program. And normally I'd say not so fast, but in that situation I'd say not so slow. We've demonstrated with customers that we can go from yeast strain identification to generating 25% of the global consumption of a chemical ingredient within 12 months. So just think about that. They're struggling with the volatility in the supply chain, and within 1 year, that's completely swapped out. Now they have complete stability, reliability in their supply chain. They have the cost, performance, and quality that's actually exceeding what they were using before within a 12-month period. Think if you brought that to your commercial team, what you could do in terms of opening up market share, right? Because market adoption is very much dependent on supply chain volatility. Yes, that's a great product. However, I can't rely on it being there. So I'll cut you in a little bit, but I'm not going to cut you in a lot. Examples of success. Well, these are the brands parked within some of the market shares that we've been into, the markets, not market shares, markets that we've actually been able to get into. So whether it's cosmetics, pharmaceuticals, solvents, lubricants, jet fuel, diesel fuel, nutraceuticals, all from yeast, right? That to me still is kind of the most puzzling thing when I keep going back to that idea. All these chemicals, all these ingredients from yeast and fermentation. Now, how do we benefit then by putting the yeast to work? Well, we offset those sources of volatility. By replacing oil, we take out the volatility in lubricants, solvents, even jet fuel, by replacing low bioavailability on plants and animals, cosmetics, fragrances. Let me just also give a little bit of a shout out to my quality team also in terms of what we have to do. Because a lot of times people think about these processes and they're very concerned about the quality. You look at something like jet fuel as an example, right? 19 assays, over 51 characteristics. And then we look at both process and assay variability, and we put 3 sigma limits against those specifications and subtract that off of that. And we still meet all 51 characteristics easily. When we have some of the folks from the DoD come out and take a look at our fuels, and it's basically water white, they were shocked. They kept asking us, this is your fuel? And they expect the yellow tinge, the darkness, what you typically would see of fuels. So the quality is absolutely spectacular. Performance of these things, exceptional. So not asking organizations to make the different trade-offs in terms of how they can address sustainability. You can't have it all. So in conclusion, I would just ask the organization in terms of sustainability, what could we do to help you create a more reliable, stable supply chain with exceptional performance, exceptional quality, build a better business, build a happier customer, and of course, achieve having a happier planet. Thank you.
So Howard, I love all those happy planet, happy customers. Now, you heard the discussion about the digital supply chain. Did you hear anybody talk about putting yeast to work or redesigning factories?
I haven't heard yeast too much in this discussion so far today. No.
No. And, you know, when you think about new business opportunities, right, you know, how should they think about it in making the digital pivot? I mean, you know, if they had a magic wand, what could they do with yeast?
Matching yeast to digital pivot? I'm going to give you the best answer I have on that one, which is I have no idea.
You have no idea.
How you're going to connect the digital supply chain to yeast? It's really more, in my mind, around sustainability and volatility. Now, there might be some connections in those, but to me, just the obvious answer that might be apparent to my teachers here today might exist, but it isn't obvious to me.
So, you know, my discussion with John as I went to Shanghai, and he talked about waste streams, right? I said, John, what is a waste stream? What are you feeding these yeast, right?
So in the particular example I just showed you, it's sugar cane. So we need sugar for fermentation, right? That's kind of an obvious thing. Whether you're making our chemicals or you're making beer, you need sugar. So what you can use, though, is any cellulosic waste stream. So anything that has a C5, C6 sugar in it. So whether it's food trimmings like a pulp from olives or from citrus, whether it's wood trimmings, any of those things can be used as a waste stream to feed this process. And when you think about that, what's the one thing that's not shrinking as we grow in this world? Waste streams, right? So having waste streams feed this process would be a very sustainable way to run it. And in fact, for the existing process we have right now, what comes out of it is actually used as fertilizer and high-value animal feed. So nothing's wasted in this either. And even the sugar that we bring into our plants, we take the sugar from it, burn the stalks, create the energy to power the steam generators to provide the electricity. So for the most part, it's about as wholly contained in operation sustainable as it can possibly be. And to the extent that different companies like to partner and exploit waste streams that they either have or know, we could utilize that in this and then get the win-win from that.
So when you work with companies, do you engage at the R&D level on product innovation, or the corporate social responsibility leader, or the supply chain leader? Where do you connect?
It's usually somewhere in the R&D space or the commercial space, because it really starts with what is it we're trying to replace. And of course, the challenge and the suspicion to some degree is, can you actually replace our chemical and our ingredient? Right? And some work needs to be done, and we can do proof points. We can do proof points on small scales. And once they actually see that it can be done cost effectively, and provide both the quality and performance they need, then typically things tend to advance pretty quickly. But that proof point needs to be there, because obviously you're not going to put further volatility in your supply chain by taking risk on what a lot of people might seem as an unproven technology until they actually get to experience it themselves.
Well, John and my conversation was, what about wild yeast, right? What happens if yeasts get outside your factory, and do they take over the planet or something, right?
Yeah, so everything that comes out of our fermentation process is dead yeast. It's dead by the time it leaves. By the time it goes through centrifugation and distillation, there is no yeast left in there. There's no bioengineered material left in it. We've done testing 5 ways to sideways to prove that, so there's really no risk of contamination. And I'll tell you right now, Brazil, a highly agricultural country with some of the most strictest requirements in the world around biology, they would not let us bring the yeast strains into the country if they felt there was any risk, either in the yeast that we're bringing in or the processes in which we use.
And why Brazil?
Sugarcane.
Sugarcane.
High bioavailability.
In sunlight, right?
Yeah. And it's Brazil.
Yeah, Brazil. Well, thank you very much.
Thank you.
Okay, we're going to bring Howard back to the stage and ideate with our speakers a little later on.